Let's just start recording.
I
wonder if we'll show it. Okay. Yeah.
All right, guys, let me have your attention. I'm going to just make some announcements.
Yeah, go ahead.
So as you remember today, we're going to have a speaker, but before I introduce him, he's going to set things up. So related to the final project, that's going to be teams of two. You don't have to be two people. You can be just one person if you want to do it on your own. But for the group of people who want to be in two-group team, but you don't necessarily know anybody else at this point, you don't know how to be paired up, please send me an email, let me know who you are, and I can compile that list, and at some point we're going to make something of magic. Okay? So if you're looking for a partner, send an email to me, and I'll pair you up with someone. Today and Monday, we're going to have a guest speaker, and on Wednesday, we're going to have a quiz. Did you say quiz? Yeah. So on Wednesday, we're going to have a quiz. Quiz and then lecture. Friday, we're just going to have lecture. And then the following Monday, the November 21st, is going to be your other lecture. Okay. Any questions? I'm sorry? So we had discussed it, and I think we came to a conclusion. So we are going to, Greg, can we have these slides from you to?
Yeah, of course. I'll send you a link.
We will actually quiz you on questions straight from these PowerPoint presentation slides, as well as operator overloading and dynamic memory management pointers. Okay. So you good?
Yeah.
All right. So
looks
what
like
I'd
we're
like to
running
do
good.
is introduce to you Dr. GregGay. He's one of our most recent hires. His area of expertise is software engineering. So he knows the field far better than I do, and he's going to give you some presentations, some basic ideas as to the requirements, test cases, and so on and so forth today and on Monday. So be nice.
You don't have to.
Did you want them to interrupt while you're talking?
Yeah, that's fine. If you have questions, that's fine.
Okay.
All
So
right.
it's all yours.
Yeah, so you guys have this final project now, right? And you need to do a little bit of requirements, a little bit of design, a little bit of testing. So they thought they'd have me in to talk to you a little today about software requirements, next Monday about software testing, right? So I've got a whole bunch to get through, and I'll get on to that since we're already running a few minutes behind. But if you have any questions, just let me know at any time. That's totally cool, right? So anyway, when you design software in the real world at work, you typically kick things off with what's called the requirement specification phase, right? And that's before you start coding, right? Before you even design your class structure, you have to decide what the heck that software is going to do. What features does it need? What should the resulting output be? What defines the correct software behavior? And that's where the requirements come in. The requirements define our goals for the software and what we promise the final product is going to do. Right? So if you want kind of the clear textbook definition, a requirement is a singular documented physical or functional need that a particular product must be able to perform. The software has to do something. It has to have, and these are constraints on what it does. These are essentially a list of items, a checklist you have to go through, and your software has to meet these to be considered correct, right? There are a set of promises. Here's what the system will do. Here are the constraints it will follow, and here are the properties that need to be met before we can release this product and consider it finished, right? So, just to give you a quick example, here are just a set of 5 related requirements for the software for an infusion pump, and you don't really need to know about the actual medical device. But this kind of gives you an idea of what we're looking at, right? So the application is going to allow them to configure the patient information, right? And then get into a little more detail. Well, they can enter the new patient data only when the infusion pump is turned off. You don't want to change your prescription while it's in the middle of administering medicine. That kind of makes sense, right? It's going to perform all patient and drug data validations after the values are entered. It's going to request confirmation before starting the infusion. And if it's in progress during configuration, then it's going to continue with the existing prescription until the clinician says, hey, change this. But in any case, this gives you an idea, right, of what you should be expecting and the kind of level of detail you want from your requirements. And you might end up with dozens of these, with hundreds of these even for a complex product. But, quick bullet points. Do this, do that. Right? Now, a requirement in the basic form like you saw there is typically a very high-level statement of something the software needs to do. It's, some property that must be met. Most requirements are accompanied by a more detailed specification, and this is something really for the engineers, for the developers who are building this. But it's a comprehensive description of how that requirement is going to be met, how it's going to be realized in that software. The terms requirement and specification are often thrown around pretty interchangeably because they all go in the same document. But it's a difference to keep in mind, right? Requirements are often what you're promising, and they're often something that's come up with not necessarily even by the developers, but by your stakeholders, your clients who've ordered the project, your management, right? It's often things at the level that can be used to communicate and get feedback. But if you need that more detailed information, then you can fill it in to kind of inform the actual people coding the system, hey, here's what you need to know to fulfill this requirement. So again, kind of give you an example of what I'm talking about here. Your requirement might be that the user has to set a password to control their account access. Pretty typical, nothing too unexpected there. But then you might go into a little more detail in your specification. Well, it's got to be at least 8 characters long, no more than 16. It's got to contain lower and uppercase letters. It's going to be hashed and stored in the database. And you see here a reference to a different requirement that's going to fill in, well, here's how hashing and storing works, and right? And so the original requirement is good for that high-level purpose. The user has to create passwords. Somewhere else it probably says they need a username, right? And this isn't enough to implement the function on its own. So the specification details come in and say, fine, it's not just a password, it's all these other details too. It's got to be this number of characters. It's got to have some special letters in it, right? And this could go on a bit longer too, as you can imagine. Got to fit this on a slide. But you need enough detail to completely and clearly specify the rules that this password is going to have to follow and how the system handles this functionality. Right? But here's the thing, and you see this with this link to another requirement. The other thing to keep in mind here is that these should be one singular feature of the system. You don't want to crowd multiple requirements into one. This is something that should be clear, easy to read, very easy to understand, and something that once you build the software, you can ensure that this is being met, right? But one clearly defined requirement, one clearly defined property per requirement. Don't start combining a bunch of those into one. And so these requirements and specifications are a description of what the system should do, right? These are essentially your blueprints for what you're about to go and build. And before you go and build it is worth spending the time sitting down and going through and really thinking through these. Most of, and I don't have the data here with me, so the number I'm just going to make up off the top of my head, but there are something like 60% of budget overruns, schedule overruns, and projects really come down to mistaken requirements. You come up with something that ends up not being what the client actually wanted. You forgot to specify different outcomes of conditional functions. You left out error handling, right? Those sorts of things. So it's really important here to spend time on these requirements. And these requirements to capture the what of what the system is doing, not the how. So they don't capture design details. You don't talk about class structure here. You don't talk about the individual methods in your system. But you take this system, you treat it as a black box, and you say, fine, if it's going to have these functions at a high level that the user can access, if you pass input, you should get this kind of output from it, right? This is what the acceptable behavior of all of these features is. But that said, high level doesn't mean low detail. Your requirements need to be detailed enough to distinguish between the correct system and the wrong system. It has to make it clear that when you use a function, here is what the resulting output should be. And it should be clear what differentiates the correct behavior from incorrect behavior. If there are any scenarios you can imagine that could give you errors, you should document them and state, it will not do this thing. So that when we go to code this, there is no real ambiguity in what the right behavior is. The requirements form the basis on which we judge the final product. Right, so that's the basics. That's what they are, why they're important. So let's talk some about writing these things. So there are 4 basic guidelines here we can kind of get into that help you a great deal in defining good requirements. So, common pitfalls, the sort of things you want to avoid. And the first of those, as I already mentioned, is you really want to avoid fusing multiple requirements together, right? Don't put too much information into a single requirement. Every single one of these is supposed to be one property of that software that you're building, one thing it needs to uphold to be considered acceptable. One facet of a feature, one calculation it makes, one constraint that must be followed. And it's really, really easy to go on in the requirement, and the more you do so, the more you risk not properly understanding what it is you're building. Right? The second thing is that you need to be precise. You need to be very, very careful with the language you use in writing a requirement. You don't want this to be vague, you don't want this to be incomplete, right? If you have something in there, if you have a condition, if this happens, this is what you do, well, make sure that you include what happens if it doesn't occur that way, right? Cover all outcomes of a conditional statement. These should be stated in the positive. You can't prove a negative, so if you say the software will never do this, the software will never lock a user out, you can't prove that that's happening. So instead, find a way to rephrase these in the positive, so it's something that you can verify is going on. And be extremely rigorous in defining test cases. Because eventually, what you want to do is gather evidence that these requirements are met. It's a process called verification. You want to verify that the software meets what you promised. And if you have a requirement that you can't come up with a test case for, then it's not a good requirement. You have no way of gathering the evidence that you built the system correctly. Right? So we'll look at what not to do. Let's go through some examples, right? So our first one, the system shall validate and accept credit cards and cashier's checks. High priority. Now, this looks pretty clear at first glance, but there's a bit of requirements fusion going on here, right? First of all, you're talking about validating and accepting credit cards and cashier's checks. Well, what does that mean? What is the validation process here? What does it mean to accept it? What happens if you don't accept it, right? Credit cards and cashier's checks. Again, there's a couple of different things here. Well, can you use a combination of these? What if your credit card validation fails? Do you cancel the transaction? Do you want to, do you try the other payment method? And what does high priority mean in this case, right? Are both payment methods high priority? What's going on here? Right, so this is a case where this is something that should probably be split into at least a couple different requirements, if not more. Charge numbers should be validated online against the master corporate charge number list if possible. All right, this one's pretty terrible. But I mean, right off the bat, it's pretty vague, right? If possible. What do you mean by that? How is it being validated, right? Where is this master corporate charge number list being stored? But really, it's the if possible that bugs me here. Well, what would make this impossible, right? And there is a bit of, well, what do you do if it is? If you can't connect or validate against this list, right? So this is pretty vague. The software shall not support optical character recognition for converting scanned recipes to text. So great, fine. But that's stated in the negative. So, how do you test whether a feature is not supported? Why even bother doing this in the first place? I mean, there's all sorts of things your software might not do. It's not going to build my house for me. I mean, there can be an infinite number of things the software might not do. So, first of all, make sure there's a reason to say it doesn't do something, and then find a way to state it in the way that you can test, that you can ensure is going on. And if failures occur, either internal or external, an easy-to-interpret alarm must be raised quickly. So again, lots of issues with this, but the real problem here is this is untestable. What do you mean by raised quickly? That is subjective. That's going to have a different meaning to every person who reads this. What does easy to interpret mean? I mean, if the thing's exploding, that might be easy to interpret, but that's a bit subjective again. So this is a case where you really have to go through here and be clear what you mean. Don't just say it's raised quickly. Say, well, the alarm shall be issued within 2 seconds, right? Don't say it's easy to interpret. Decide what is easy to interpret. Well, it's going to sound at over 90 decibels, right? Something like that. Look at your requirements and ensure that you could take those and translate those into test cases to ensure the software then meets those requirements. Any questions so far? Yes?
So when you're writing those, you really have no specific knowledge of what's going on. So just with the validation thing, you can't assume, well, I know vaguely how that's going to happen. It has to be explicit in the requirement.
It should be, yes. So when you start writing these, and these usually go through several rounds of revision, right? But when you start writing these, you haven't started building software. You're just sort of figuring out what the project is, right? So you start listing these, and then you can kind of go through into a cycle of revision on these, but you really want to end up at a point where it's extremely clear, where you could take this and start coding and have a reasonable idea that what you're building is the thing you want to sell in the end, right? Does that answer your question?
Yeah.
Cool.
I do have a second.
Yes?
With regards to I think it was the previous slide, when we were talking about you're not stating things in negative, and you gave the example. How do you specify things in the affirmative tense that you don't want it to do?
So this is one that is, kind of contextual, but let's say that you had a software that could lock people out after a certain number of invalid password attempts. And you might have some conditions on that. You might say, if the number of attempts is set to 0, well, the software is never going to lock somebody out. Now, that is probably what you want to happen. But what you want to do is kind of back that up. Either A, find a way to state that in a way that you can ensure, or B, kind of back it up with specific scenarios. Under these circumstances, or if we try this number of attempts in a 10-minute period and they're not going to be locked out, you want to put enough conditions on that to where you can demonstrate some evidence that's going on. But I don't have a good example off the top of my head for how you take one and kind of translate it into another form. But it's just something to be extremely careful of. Sometimes you can't avoid it, but whenever you can, if you have some alternate version of this functionality that kind of gives you the same thing you want, but something you can also verify is going on at the same time, then that's what you want to go with instead. Sometimes you just can't avoid it, though. It's something to be avoided, not something to never ever do. Any other questions? Cool. So let's go over. Those quick guidelines are going to help, but when you sit down to write out your requirements, there are a handful of qualities we want to make sure those requirements fulfill. Right? And if you can't check each of these off, then there's something wrong, and you should go through and refine these requirements. So every requirement should be correct. It should be free from mistakes, from faults. And now this is obviously something that's the hardest to be sure of, and it's something that generally it's you aim for this, and then you find out later you made a mistake. Right? There's not a measurable way to say this is absolutely 100% correct. But you should be able to independently verify that what you have written is what the software should be doing. If you have a requirement that involves a calculation being made, or a particular equation, fill in examples, right, to make sure that what you've written is what you actually intended to be there. If it's related to a particular computation, go through example executions. You don't have source code, but you have a rough idea of the process. Step through that process and make sure that you're getting the correct result. Write test cases, right? But in any case, you want to try and ensure that the requirement is correct, and then if you follow this, you're going to get what you had in mind because the requirements are what you're following as you build this code. Every requirement should be precise. Oh, sorry, go ahead.
I'm still not really sure to me by correct. Can you possibly give like an example? I think it just like, do you just mean in line with like the bigger picture of like your software?
Yeah, sure. So if you intended your function to give you a plus b, and then you wrote in your requirements document that the equation is a minus b, it's not going to be correct, right? It's not what you actually wanted it to do, or what your client wanted you to do, right? So it differs from some ground truth, which is usually either you just made a mistake when you wrote it down, or the people paying you had something in mind and you differed from what they had in mind, right? But I mean, just like when you write your source code, right? You can make mistakes when you're typing it up, and it either won't compile or it will compile and gives you the wrong result. This is another human product. You could make a mistake when typing out the text, and you read this later and go, "This isn't what I wanted at all," right? So this is more of an aspirational quality than something that you can run a compilation and check for. A little less aspirational is that your requirement should be precise, unambiguous, and clear. And this all comes down to what you're writing, right? This is a big one. Every item should not be vague. If you read a statement, it should have a single interpretation. You can't question its meaning. And the specification of that requirement should be easy to read, right? It should be easy to follow, even if it's relatively technical. It should be written and structured to be clear. And there are templates you can use to kind of ensure you're in the right direction, just because you can go through those and break this down into each of these fields. And I can probably send an example out along with these slides of that. But in any case, you want to be able to look at the language of this requirement, read it, and have a very clear idea of what to expect from this. The requirements should be complete. They should cover all aspects of a property being asserted. Right? Like I said before, if a condition is specified, make sure all possible outcomes of that condition are present. But there should be no question if you're following this requirement, if you are performing this function, there should be no question of what the outcome of it should be. Right? If you provide erroneous input, then if your requirement should cover what happens if that's the case, right? If you have like an ATM withdrawal and you don't have the funds in your account, well, you should cover what happens if those funds don't exist and what happens if those funds do exist. Right, make sense? Yes?
So all these requirements apply to just the single requirement that, sorry, but like you had on the first side like examples of this.
Yeah.
You had like the types and then subtypes and then exempted.
Yes.
Do you want should all of this apply to just like the first statement, or should all of this be clear
Through everything, yeah, through everything. Every requirement should be consistent. So within the requirement and between multiple requirements, you don't want them to contradict each other, right? And you should watch out here because contradictions can be fairly subtle, especially between multiple requirements, right? If you have something in place that says the system must respond to all requests within 2 seconds, and elsewhere you say, well, the help text should be displayed within 3 seconds. Well, there's a contradiction there. One says 2, one says 3, right? You might sometimes accidentally promise 2 different responses to an input, and you should be clear. Well, do both of these happen? Do just one? If just one, when do these occur, right? Is there an ordering on these? So as written, for instance, the 2 here contradict each other, right? If they select that reset password option, well, an email is going to be dispatched with a one-time use link. Or if they select the option, they're going to be prompted to enter a new password along with their email address. Which one of these happens? Do both of these? Probably not, right? But in any case, watch out for contradictions between and even within single requirements. The requirement should be relevant, and that almost should go without saying, but there should be a reason for a requirement to be in your document. As you're reading it, you shouldn't be confused as to why this is there, right? This is a pretty dumb example, but the software is not going to require Adobe Acrobat. Well, who cares? Do you need some other PDF reader? Do you assume that some exists? Have a reason for including a requirement, right? And I've kind of already been stressing this, but all of these requirements should be testable. As you build the system, and once it's being evaluated by your customers, it has to be possible to determine whether the software does what you promised it would do in these requirements. You need to be able to argue that a requirement like an alarm must be raised quickly is being met. And something phrased that way is going to be unacceptable because the concept of quickly can't be tested. It's entirely subjective. And if there is subjectivity in the interpretation of your requirements, then you're going to not going to have a very clear idea of whether what you built is working as expected and really does everything you promised it would do, right? This is probably the most important quality of any requirement. Can you come up with at least one test case to demonstrate that it is being met? Because in the process of going through and coming up with these test cases, you are suddenly going to find out a lot about your requirements, right? You're going to have a very clear idea of how to go out and program those by looking at those test cases. You're going to find out if it's ambiguous because, well, when you go to write the test, well, it's going to be awfully hard to do, right? So by ensuring that a requirement is testable, you almost certainly have a correct requirement in the end. It's more likely to be complete and consistent. Also, every requirement should be traceable. That means we should maintain links between related requirements. It's important that you can follow those links to quickly find related requirements. Now, this is important when you go to program the system because then you can find everything that's related to each other and have a clearer picture of what you're programming. It's especially important when you go through and change your requirements, right? Because when you make a change to one, it's going to impact all of the others that are related to it. And you need to be able to find those and make changes to those as well. And your requirements should be feasible, and this is another thing that I almost shouldn't have to state, but everything you promise the system should do should be something that you can actually accomplish within the time bounds you set for your project and within the expectations of your project, right? You should never promise something that isn't going to be completed, and you should never promise something that would be nice to have, but that you aren't saying will absolutely be there, right? Once you put something in your requirements document, it should be something the final system is realistically going to deliver. Okay. Any other questions so far? All right, cool. So let's just toss out a few more examples. The product shall provide status messages regarding background processing at regular intervals, not less than every 60 seconds. So there's a couple of issues here, mainly in terms of ambiguity and then testability, right? For instance, regular intervals, not less than 60 seconds. That's a good lower bound. I mean, you can ensure the lower bound. What's the upper bound on that, right? It's not entirely testable as of yet. What events trigger status messages, right? You just sort of say, hey, events, regarding background processing. What are those status messages? And maybe some of these should be covered in separate requirements. Back to that, don't put too many things in one. But these questions need to be answered, otherwise you have a fairly vague, untestable requirement. Now, if we wanted to fix this, now we could come up with a series of related requirements at a far more appropriate level of detail, right? Well, so now we have an interval, right? Intervals of 60 plus or minus 10 seconds. So between 50 and 70 seconds, you should be seeing these error messages. You got a lower and an upper bounds. Much better there, right? We have an idea of what these status messages are and what events cause them now, right? Well, if background processing is going as normal, you get a percentage. There's a message displayed when it's done. There's an error message if it's not progressed in a certain amount of time. And these are logged to a certain log file maintained on your file system, so you know where to go for these messages. So this is more what you're looking for. You could ensure each of these is being met. You can write test cases to try and trigger these different conditions, right? To try and trigger different levels of background processing. And you have a pretty clear idea when you go to build the functionality what should be going on with regard to this background processing. Make sense? All right, the product shall switch between displaying and hiding non-printing characters instantaneously. Now again, we have some issues with testability. Instantaneously is subjective, right? And it's a very human idea. At the machine level, you know, almost everything you do might be instantaneous to a human observer, but this should be something defined exactly in terms of what the software is actually doing. It's also incomplete. What causes this switch? Without the inputs, without preconditions, this doesn't really make a lot of sense. But again, we could kind of revise this a bit. Well, now your entry box is going to switch between displaying and hiding non-printing characters within 200 milliseconds of a mouse release of the display button and the quick function bar. All right. So now now we dictated when we switch between displaying and hiding non-printing characters. We've dictated what instantaneously means. So again, this is something that you can verify as being met. All right, we're running a little low on time, but let's see what we can do. Now, as part of your project, from what I understand, you have been asked to come up with use cases too. Use cases are very closely related to your requirements, right? And they're an important tool for brainstorming and coming up with your requirements. So a use case is a discrete goal of a user when they use your system. It's a high-level summary of a visible function of the system, and it's a goal that an actor can accomplish through using the system, through a series of interactions between the actor and that piece of software. For instance, if you had an online banking system, a use case might be to transfer funds or to query your balance. That's something a user of this system might want to accomplish while using this software, right? And this can be a large or small function depending on the level of detail that you want to model, that you want to brainstorm at. For instance, if you, again, talking about, something like an ATM or a banking system, withdrawing funds versus validating your PIN. These are both valid goals of a user of the system, right? You might include PIN validation within withdrawing funds, depending on your level of detail you're looking at, but you might also split it off and include it as its own use case, as a goal of a user, right? A series of interactions that take place in service of that goal. Now, these use cases come with a description that details the series of interactions that are required to accomplish this use case. And you come up with these use cases and their descriptions through interviews with your stakeholders, with your clients, with anyone who has an interest or the knowledge necessary to understand your project. And you can sit down with them and say, all right, fine, if you want to accomplish this goal, what do you foresee doing to do this, right? And these use cases and their descriptions are really important because they let us brainstorm. They let us look at how the system is going to be used in relatively concrete scenarios. And from there, these are really useful for eliciting and refining your requirements, right? So you can come up with these, and we can use them to come up with your requirements or questions to ask customers during the elicitation process as you come up with these requirements. So use cases are performed by actors, and actors are roles that users can play with respect to the system, right? So actors are those who carry out a use case. And an actor can perform many different use cases. They might have many different goals when they're using the system, or many different functions that they can interact with. A use case can also involve multiple actors when the system links these actors together. Now, a single user, a person interacting with a system, could technically be multiple actors, depending on the role they play when interacting with the system. If you have a banking system, your bank teller might have both an account at the bank, right? They might be a customer, but when they're at work, they might play the role of the bank teller. Both of these would interact with functions of the same software. Now, actors also don't need to be human. When you're coming up with use cases, other pieces of software or pieces of hardware can serve as actors. If your software interacts with a database, for instance, if you log into a system and validate your password against a password database, that is an actor in your system, right? It is not part of the software you're building, but rather an external entity that is involved in interactions with this system. So keep that in mind. Now, coming up with your actors is the first step in coming up with your use cases, right? Because once you have an idea of who uses the system, it's a lot easier to decide, well, what happens when they use that system. Now, something to keep in mind and be careful of as you produce these use cases is the distinction between the use cases themselves, the goals of someone when they use the system, versus the actual interactions taken to accomplish those goals. For example, when you're formatting a document in something like Microsoft Word, you can talk about things that you might do. You might bold a line of text. You might change the bold to italics. You might copy text from one document to another. Or you might format a document, or ensure consistent formatting between similar documents, right? Now, the latter ones, format a document, ensure consistent formatting, those are your use cases. Those are goals that you have using the system. Your goal isn't to bold a line of text. Your goal is to format the document. But in doing so, you might select a line of text and click the bold button and turn that to be bold. Those are individual interactions that take place in service of one of these high-level goals. Does that make sense? Right. So when you're capturing what the system is going to do, what you want to do is capture those use cases, those high-level goals, and for each of those, to really understand how the user achieves that goal, you want to capture the sequences of user interactions that can take place to perform that and accomplish that goal, right? So you start with the goal, you start with the use case, and refine these into a series of interactions, and that's your use case description. These really do form the basis of your requirements. Once you know the interactions that need to take place, once you know the goals they lead to, well, it's a lot easier to come up with the functionality the system needs to perform and constraints on that functionality, right? You can take those interactions and transform those into a series of detailed requirements to define how that system is going to facilitate the accomplishment of that goal. Now, often there are multiple series of actions that can occur when you're trying to use a function of a software, right? A goal can be achieved through different means, through different interaction sequences. And all these accomplish the goal, all these accomplish the use case. But the order of events or the actual events might end up varying, right? And each of these is valid. So we call each of these scenarios, and sometimes too, alternate outcomes can occur. Well, you can click the cancel button to stop the sequence of interactions. Or there might be exception scenarios, cases where someone gives bad input and the software really gives you an error message rather than trying to go through the entire function. We want to capture those too. So your use case description should capture not just the one solid good single path, but each of the series of interactions that can take place while trying to perform this goal, and anything that can go wrong while trying to accomplish this goal, right? So when we write that use case description, you want to capture each of these. Now, when we go and we sit down to write that use case description, we want to have a good idea of all the different scenarios that can occur during that the general process of accomplishing that use case. And the use case is more abstract than one single scenario, right? So instead we want to present all the possible ways to achieve this goal and all the alternative sequences that can spin off of or prevent you from achieving this goal, right? And this is really important to think through these and really sketch these out and coming up with your requirements, right? It's a great way also to get feedback from your stakeholders and from your clients. So you can sit down, walk through these scenarios with them, and they can tell you about anything you're missing or any unnecessary interactions, right? In service of coming up with the software. Well, let's look at one of these. This isn't the whole picture, but just to start off, right, if you had an ATM, and everyone's used an ATM, right, and something you do with an ATM is you withdraw cash from it. Now, you can walk through the sequence of events then. What do you do to withdraw that cash? Well, you are going to insert your card. You're going to enter your PIN, right? They're going to validate that, and if it's correct, then it's going to ask you to choose your account. And when you choose your account, you're going to enter the amount of cash you want. And it's going to check whether that's in the account, and if it is, they'll give you the cash. And then you'll go back to the main menu. Right, so I mean, pretty standard series of interactions. But you see the back and forth there. You do something, the system does something in response. You take the next action, the system responds to that. Until at the end, you've accomplished what you've set out to do at the beginning, withdrawing your cash. Now, as you look at this, though, you can kind of see, well, what are some alternative or exception scenarios that can occur and spin off from this? Well, if you think about using an ATM, there's usually a cancel button. So what even though you validated your PIN, well, before the cash comes out, you might click cancel to go back to the menu. There's an alternative scenario that can occur. What if the funds aren't in your accounts? What if you select you want $300,000 and your account is $10 in it? Well, something's going to happen, right? Unfortunately. So there's an exceptions path right there. Well, if the funds aren't in your account, then an error message should be displayed and you return to the main menu, something like that, right? So we can take this and we can kind of spin it off into a full use case, and I'm omitting some stuff here obviously for space, but the same basic course of events occurs, right? That's your standard path to accomplishing your goal. Well, you can also include these alternative paths. At certain points, you can cancel the transaction and go directly to step 10, complete the use case. If you don't confirm the account somewhere in there and the step I've left out, you proceed directly to the end. Well, and there's exception paths. If there aren't sufficient funds, give the error message, return, proceed to step 10. We also can include some preconditions and postconditions. What are things that must be true before we begin this use case? And what are things that the permanent side effects left over after you complete this use case, right? In this case, well, you're going to have to validate the PIN before you can withdraw funds. So that's a precondition. That's just linking, hey, there's another use case, go check that, make sure that's done first. As a postcondition, well, you have less cash in your accounts, right? So there's a side effect left over from accomplishing this goal. Does this make sense? Right? Any questions? All right. Let's see. Yes.
So with something like layers of detail, how do you really start out? You kind of start out with your actors and then your use case and then narrow down your requirements, or is it kind of like personal preference on?
There's a bit of personal preference, but yeah, you can imagine as a general process as what would be easiest. Well, you generally have, here's an idea of what the software should do, but it's good to, I would say it is good to first think up your actors, who's going to use the system, think up what they want to do with the system, get that use case written down, and then use that to come up with your requirements. Because usually, your requirements tend to be broken down by functions your system offers. The high level, well, it's going to let you withdraw cash, it's going to let you transfer funds. And then for each of those things, you'd have a series of requirements. So that's why the use cases are really good as a starting point, because it gives you an idea of what has to happen to perform a function in the system. Let's say you had a course web page and you're going to distribute an assignment. So another quick example, but you have an instructor who's putting up the assignment, right? They're going to upload the assignment. If it's completed successfully, they're going to be asked to look at a preview. If you approve the preview, the system is going to ask for a due date. You enter a due date. It's going to be made readable for students, right? So again, very basic series of interactions here. We have a couple things that can go wrong or alternatives. You could cancel at any time, or the upload could fail, and you account for those. And there's some preconditions, as in the site has to be configured before you can put assignments on it. But again, I think you get the rough idea here, right, of what you're looking at. These use cases are really, really nice. These are things you should always be using, because requirement specification is actually really hard. Especially in terms of things like getting it complete, getting every function in there, every constraint in there, error handling, all of that. Specification is often the hardest part of development and the hardest thing to get right. And in that quest, use cases are a really powerful tool to deal with these unknowns, right? They let you take what the user has stated and begin to model the system and come up with these requirements. Right? It's really useful for figuring out who is using your system, what they want to do as they use the system, and how they go about doing that. In the end, you get these use cases, and each of these tends to correspond to a pretty large number of requirements. And it's a really good way, like I've said, of coming up with those. So to keep in mind, every use case is going to correspond to a large number of requirements, because these are high-level goals, right? These requirements there are kind of lower-level statements of how to make that goal a reality. These use cases give you a good external view of the system, right? They don't tell you what's going on inside. They don't really tell you what the code is doing, and that's not their intent. You design the system later on. But they give you that starting point and that view of what the system is going to actually do. There's no real rule of thumb for how many use cases you should have. Again, it kind of comes down to what kind of functions your software is offering, and are there cases where you should break these down at a smaller level, like validate PIN as being its own use case versus just part of withdrawing cash, right? Next time I'm going to be here and talk about testing with you guys and the basics of that. If you have questions, feel free to email me or come see me, or I can answer them now if you want to, right? Cool. Yeah, there you go. All right. Yes. Yeah, I'm going to email him the slides and he'll put them up.
Acting is very symbolic. It shows that I back one around.
Let me just get something to